Okay, guys, so we're just going to wrap up. We're just going to talk about a few more things. Hopefully, watching that video and seeing this illustrated helped a little bit because I actually had the little person standing there and you saw how the person actually was rotating through the bulges that actually are the tides. That was the video y'all watched. This is another little illustration that kind of hurts to look at because it goes so fast and I can't slow it down. But you'll notice it's showing spring tides when you're at new moon and full moon. And when it's at spring tides, the bulges, the gravitational pull is stronger. Okay. And then when it's on neap tide, it's over here at first quarter and third quarter. And the bulge or the tides are not quite as, even the high tide of the day is not going to be as high when it's neap tides. So it depends on where the moon is in its orbit around the Earth. So that's going to change each week. Because remember, it takes about 28 days, and so that's about 4 weeks. So each one of these quarter turns is a week, 1 week, 2 weeks, 3 weeks, 4 weeks, 28 days. So about every week, your high tides go from being like maybe a neap tide that's not quite as high to a spring tide that's a little bit higher to a neap tide that's not as high. So that's kind of what this is illustrating. It just hurts to look at for too long, so don't get hypnotized. Okay, this is what you saw in the video. That place in Nova Scotia, which is in Canada, that period, 6.5 hours, it shows it go down, and then another 6.5 hours later it would come up. But I think the one in the video was better. Okay, so the last thing we need to talk about, and I think this is already actually in your notes, you don't even need to write it down, so this is a chance for you to just kind of try to absorb. Many people believe that the rising moon is larger when the moon is than when the moon is higher overhead. So people feel like when the moon is rising and it's kind of lined up with the horizon and you're looking out at it, it seems to be larger than when it's high up in the sky. But this is actually just an illusion. The effect is almost entirely an illusion, although scientists they have some theories as to what causes it, and we're going to learn about those. But no, they really, even after hundreds of years, can't really all agree on it. So the effect is basically almost entirely an illusion, although when the moon is closest to the Earth in its orbit, like when it's actually orbiting, when it gets a little bit closer, it does appear about 11% larger. The rest of it's in your head. So they're basically saying here in this picture where the moon is coming up over the horizon, it appears larger. And one of the theories, and I can't remember the name of it, it's going to be in the video you'll watch after this one, is because it's being compared to smaller objects around it, like smaller trees. So you have a little bit of perspective, and so it appears huge. But when it's way high up in the sky, there's nothing around it, especially as it really gets up there and it gets darker. There's nothing around it except space and stars, and so it looks a lot smaller. So that's one of the illusions. So this is kind of another little optical illusion kind of thing. I'm trying to see. Oh, it didn't work out as good. I cut and pasted this from another page. And, oh yeah, it still looks, okay. So depending on how you look at it, it could appear, and it didn't cut and paste as well, that in this picture, this sphere seems a lot larger than in this sphere, it seems smaller. But they're actually both, if you got a ruler out and measured them, they're both exactly the same diameter. So because it's set far back, and when you learn to draw in art and you learn as things approach the horizon, you draw them to get smaller. So because it seems, that's another one of the theories that why it looks larger is because as things extend towards the horizon, we expect them to get smaller. And when they're up close, we expect them to be larger. So it's just another optical illusion. Like right here on this one also, if you were to measure these, they are really the exact same size circle. They just looks larger when it's farther away because it's by these tiny little trees and all these other things that we've drawn the perspective to look smaller as it's far away. So that's kind of cool. They're actually the same size. You can measure it if you want. So the last part is really just learning about the moon illusion. And I have another little video I want y'all to watch after this that explains the moon illusion really well. So you have this in your notes. You're going to watch one more video on the moon illusion. And then to finish up today, there's a Google form attached that you need to answer a couple of questions to make sure that you were in class and you were paying attention and you were finishing up your notes and you were watching the assigned videos. It's a way to let me know you were here and you were paying attention and you were learning something. So tomorrow I'll be giving you back your interactive notebooks. Some of you have already gotten them back because I've been slowly grading them. But you'll get them all back by Wednesday, and we'll do a couple of pages in there on Wednesday. And then we'll move on from the moon and kind of start wrapping up astronomy. Make sure that you are checking the phase of the moon each night. Okay, if you get behind a day or two, you can go to those websites and look them up. But a couple of nights have been really cloudy and you can't do anything about it. But tonight it's clear. I'm making this on Monday night. It's clear. Hopefully last night you went out and were able to look. But it just depends on your weather near you. All right. Hope to see you guys on Thursday in Math Zoom. See you later. Bye.